Hi and welcome to this session on Migrate your ETL to Azure Synapse Workspace. My name's Connell and I have been working with data for about the last 20 years. I originally started working with Access and then moved into SQL Server and spent a bit of time working with Dynamics CRM. For the last 2 years I've been working with Sword, and for the last year we've been delivering ETL and ELT with Azure Synapse Workspace to deliver modern data warehouses. What we're going to cover in today's session is we're going to look at the tools that are available in the Synapse Workspace, the overview of those tools. So we'll be looking at notebooks, at data flows, at pipelines, and then we'll demonstrate some of the capabilities of the platform. What it's not is we'll not be looking at a detailed exploration of ETL and ELT. We will not be having a technical documentation discussion about Azure Synapse Workspace. I won't be discussing Purview data management for that at all, and we won't be talking about Azure Synapse, formerly Data Warehouse. So we'll not be looking at that enterprise data warehouse solution. Considering ELT in a modern data warehouse, our main considerations would be if our schema changes or if something changes about the data we're bringing into the process, can we respond quickly? If our data volume expands, can we scale up to increase the capacity so that we can cope with that expansion? If our data is of different types, can we support things like JSON, for example? And also, we want to have a platform that we're not having to spend lots of time managing our resources. We don't want to spend days building and maintaining SQL servers. We want to get on with the business of managing the data through the flow and presenting the best value data to our end users. The various sections of Synapse Workspace, we have the data where we have linked data sources and workspaces, so any databases we create. We have the development where we are working with notebooks, with data flows and pipelines to conduct and manage our ELT. We want to be able to monitor it to see how well it's performing and getting any error details. And we want to give other users access to the workspace and connect to new data sources. There are a whole range of different connection types, and this negates the need to use third-party connectors. So for example, Kingsoft had a really good Dynamics connector for SSIS. However, it was expensive. You had to buy it, and it worked in different ways for different platforms. These are now out of the box. So we've got this wide array of different connections, and we can use those to connect to all sorts of different types of data. We can do on-premise connections very simply through a self-hosted integration runtime. And they're simple to repoint using some command prompt, and I'll detail that at the end of the presentation. We can have an organized approach to our connections. We can use folders to make them easier to sort through. We can minimize the number of connections that we have to make it easier to find when building different components. And we can explore our data. So we can use the connections that we have to do queries or look at different tables, and we can dynamically change the connection that we have. Sparks is version 2.4 of Sparks. It's the open source library, so we do lose some of the proprietary stuff that you might get with Databricks. It doesn't have synchronous co-authoring, and actually that's a bit of a gotcha for Synapse in and of itself. If you have multiple users working on Synapse, the state of notebooks and the state of data flows are those which they were when you connected up to Synapse. So if you do some work and then publish it, and then one of your colleagues comes along with an unrefreshed browser window and suddenly makes changes to the same component, then it can overwrite your changes. However, the Git integration does help to mitigate that to some extent. It's aimed at modern data warehouse, which is handy because that's what we want it to do, and it's linked to the data lake that is connected to your Synapse Workspace. So you don't need to mount any storage or anything of that nature. Scenarios for using it might be converting text to Parquet, sending emails for analytics, refreshing your Power BI integration data sets, logging errors. So if, for example, you've got a situation where you want to log an error, you could pass that through a Sparks notebook. Serverless databases allows for storage in Azure Storage to be read and written using notebooks or data flows. And any Sparks database that you use will synchronize to SQL Serverless. So if you're working solely in notebooks in Sparks, all of that will be available through SQL Serverless. You can then use traditional tools. Power BI we've described there, Azure Data Studio or SQL Server Management Studio to connect to the data that you have directly in that serverless environment. So you can use your standard tools. And certainly one of the patterns is to store your data within your data lake and using serverless SQL, send cached data sets up to Power BI. You can see the scenarios for using serverless. So a quick exploration of your data. If you just want to see what's inside your data, how that data is shaped, what kind of level of data, number of rows and such like, you can do that. To use it as a logical data warehouse to do some further transformation. The external data can be connected to serverless via tables or through views. So external tables and open row set views. Tables are cached and views are not. Tables are more performant than views in a scenario where, for example, if you've got multiple reads of the same table using CTEs, for example, then it will read the table once and it will know what the structure is, so it will keep a cache of that. Open row set won't do that. Views are quite quick to build. You don't need to supply a schema because you're just doing open row set. So if that data is changing, is in flux, then views using open row set are quite handy because you don't need to specify the data. Whereas if you're doing an external table, then just the definition that you've supplied in that external table definition will be available to you, even if new columns were to come along later. Data flows, if you've got any familiarity with SSIS, then data flows will be very straightforward. Because you're working with the data in real time, you can see what's happening to data. You can check the changes on your data in real time. There's a wide selection of functions, so you can transform the data in a lot of ways. One gotcha that I would say is that the decimal values in the pipelines do default to 10.2, so it's worth checking and explicitly casting if you need to have better precision than that. So approaches to moving ETL or ELT into Synapse. Azure Synapse Pathway is a new tool that's still in preview, and this allows for some analysis and conversion of code. Currently, the support is for SQL Server, for Snowflake, and Netezza. So it's a good way of picking up existing SQL, any store procedures and such like, and that being transcribed into a structure that you would be able to use in the Azure platform. ETL options, we've got a few options inside here. One of the things that I would suggest is for these top three sections, so for this set here, what you would perhaps consider is to redevelop these. So if you custom coded or scripted solution, then because there's no metadata lineage in the code, you might want to bring it into Synapse. They're hard to maintain if the authors go. If you're using legacy data warehouses in SQL in any of these, then that might not transfer very well into Synapse. So you might want to redevelop, and certainly that is the preferred approach. For these last two, then I think what you would be looking at for these ETL platforms is maybe looking at, is there a way to change the destination so that it's pointing to Azure Synapse, or is there a way to, is there an available platform within Azure that you could use to, instead of the on-premise one, to perform the same tasks? Okay, let's move into our demo. The home page of Synapse allows us to access an ingestion wizard, which allows us to specify a source, a destination, a few other settings, and quickly get data into our Synapse. In the Learn section, we can browse a gallery of samples, and the pipelines have icons below them which indicate which components will be added to this pipeline. I've added the Parquet CRUD operations pipeline, and this contains a data flow and a couple of Parquet samples. When we come to manage our Synapse, we have analytics pools for SQL and Apache Sparks. SQL has a built-in serverless SQL pool, but we can add a dedicated pool from here as well. Dedicated pools have additional components such as stored procedures and functions, but they do cost more. Dedicated SQL pools are costed by the amount of time that they are live and not the data throughput. As a consequence, it is good advice to pause your SQL pools, your dedicated SQL pools, if you're not using them. I have created a small Sparks pool, and this is sufficient for the demonstration that I'm going to do today. Integration runtimes come in two flavors. Azure integration runtimes, of which the auto resolve is created for you, controls things like data flows and pipelines. Self-hosted integration runtimes are specifically used for pulling data from your on-premise network into Synapse. Access control for Synapse is controlled through the workspace itself. And this is a bit of a gotcha for AD admins who sometimes give access through the portal, but not through the workspace. You can add users or you can add groups, and I would recommend adding groups. You can configure a repository either in Git or in DevOps. Linked services are connections to data sets or to data sources that we can use to connect to data for our Synapse workspace. The Azure Synapse Analytics and Azure Data Lake Storage Gen 2 have been added by default as I created the workspace. I've added Azure SQL Database and SQL Server. The sample that I added has included Azure Blob Storage. Next to each source is the number of related datasets that are used, and as you can see, here there are 3. Let's explore these. As we look at these connections, we can see that the file path is remarkably similar. But we have 3 file paths and 3 different connections. And if we have further more file paths, then you can see that we're going to start getting a lot of connections. Is there a simpler way to do this? You'll see my Parquet. I've got Parquet for no parameters and Parquet parameterized. And this feels a much simpler way to do it. Let's explore this pattern by creating some datasets. First of all, I'm going to create a folder for these datasets. And what this does is it just really gives me a way to organize my datasets. It doesn't necessarily help when I'm selecting them later on. So create a new subfolder, and I'll just call it on-prem SQL, which is a bit of a clue to the type of dataset that I'm going to create. First of all, we'll create a dataset without any parameters. Because it's SQL, I'm going to choose database, and then I can filter even further by selecting SQL. rename the data set, and then I'm prompted for a linked service. I only have one available, which is the on-prem SQL that I had specified earlier. I could now select a table, but actually at this point I don't want to do that. From this connection, I can create one that is identical by using the clone function. But this one I'm going to change slightly. I'll rename it first of all. And then I'm going to add a couple of parameters. The first one for schema, and I'm going to default this to DBO. And this means that should I not need to supply it or not need to change it, it doesn't need to be supplied. The second one will be called table. Once I've added these, I can modify the connection with this edit checkbox here. This provides two boxes, one for schema and one for table. And I can add dynamic content to select the schema parameter and the table parameter. So there we are, two connections, one without a parameter and one with parameters for a schema and a table. Let's consider how we will use these. I'll create a pipeline, and this will allow us to see how these connections would be used. I'll use a copy data transform, and in my source I'll select my on-prem SQL no parameter. Now, because we haven't actually specified anything, this isn't presently going to connect to any data. However, if I select query here, you'll see that I can specify a query that will connect into a database or a table within a database. Let's preview the data and we can see what's coming through. There you go, very quick to access data. On the sync side, I'm going to select a readable form for the user, and this means that if data comes in and it's been corrupted or there's some problem with the data, then a user can go and have a look at that and just make sure that there's nothing wrong with it in the first instance. So I'm going to select delimited text parameterized. So you'll see that this has a parameter for folder, and this will be the destination that this file will be sent to. So I'll populate that, and then we can kick this pipeline off and see what happens. You'll see down here the output, and this gives us access to things like input, output, and we can see what's happening in the processing of this data. This automatically refreshes, but if it's a short process such as this, then it might be required to refresh. And there you can see within a few seconds we've captured the data. And we can look inside and we can see how many rows were read and how many rows were written. We can also go and have a look at our data and say, well, where is that data and how has it been written? So in our blob storage, we can go and have a look inside the text in NYC and inside the sample folder, and there you'll see some files that have been written from this pipeline. Now that we have our data, we've covered the extraction and loading portion of ELT. So let's consider what we can do with this data. The first statement here is just a bit of housekeeping, but what I would like to do is draw your attention to this cascade statement. What this means is when I drop this database, it clears up any data or any tables that are part of this database and prevents these from causing failures. Below that, I have a create database statement and a create table statement. The create database statement contains the name of the database and the location that we want to create it within our storage. Below that, I'd just like to draw your attention to this corrupt record statement at the end of the create statement for the table definition. Let's run these and see what happens. As you can see, they run pretty quickly. Once these have been run, you'll see that we now have this new database, Avengers Members, and it's a Sparks database. Inside that database is the table Members Bronze that we specified here. We're going to look at a couple of methods to load data into this database. The first thing that we're going to do is we're going to use this PySpark magic command. The statements above, drop, create database, and create table, we're all using Spark SQL. We don't need to change to a new workbook or new notebook. We can use the magic command to convert our code to PySpark, and this allows us to work with data frames. The first thing that we're going to do is we're going to look at the Avengers Members Bronze table and take the schema from that table and then just print it out. Here you go. We have a structure type with a list of structured fields. This has been taken from the table, so each of the names of the columns and the data types that we've got is the same. Below that, we have a couple of different methods. The first one takes the schema that we've just inherited, and it uses that as part of this data frame, and it looks at this CSV location and then creates a data frame which it prints out the first 10 rows from. Our next method doesn't use an inherited data frame, but instead looks at the file that we've got. So we're using the same file, but we're going to inherit the structure of that file and use that for the structure of this new table. We're using, in both the previous example and in this example, the permissive mode. And what that does is it will load all data, and where the data doesn't conform to the schema, it will drop the rows into the corrupt record field that we showed you earlier. Let's start this off. This creating another data frame. And there you go, we've collected this data as well. In this next statement, we're going to write these data frames to tables. So the first one, we'll take raw data and we'll write it to the Avengers Members Bronze table. And the second one, we'll use the same statement but with the data frame, and we'll put it into this new table, Marvel's Avengers. And you'll notice that doesn't presently exist, but let's run and see what happens. Once this is completed, I can refresh the tables within my database, and you'll see that I now have Members Bronze, which we'd already specified, and Marvel's Avengers. And if we look at the columns inside here, you'll see that these are made up in pretty much the same way as we saw in the table that we had specified. What we can also do at this point is we can start to query these. So let's take this table and we'll create a SQL statement. The context menu here allows us to select the top 100 rows. If we run that, you'll see that we get some output. This is the first 100 rows from this table. We can take this SQL statement and we can use it to start to transform our data. Here we have another piece of Sparks, and this time we're creating a data frame but from a select statement. A couple of things to notice. First one is that the square brackets around the names have gone. I've taken these away because these are breaking characters within SQL in Sparks. The next thing to notice is that what we don't have any longer is we don't have that DBO schema name, and again because this doesn't work with Sparks, so we're just leaving it behind. Let's run this and see what happens. So once this is completed running, what we can do is we can refresh and we can see that we now have this further table, female members, and this contains just the data that we specified in this SQL statement. So hopefully what you can see here is we could use Sparks and we could use notebooks to do the entirety of our transformations. We can take data from more than one table as part of a SQL statement and just run the data through our pipeline. But there is another way. So let's go and have a look at data flows. Okay, so let's create a data flow. And we'll give it a bit of a friendlier name and hide this properties window. And I'm going to add a couple of sources. First source, I'm going to use this Parquet no param, and I'll do the same with the second source. Now, if you recall, Parquet no parameter, we simply said, go and look in this storage, but we didn't tell it where to look. So how do we make sure that this source knows where it's going to look? Well, inside the source options, you'll see that we've got this wildcard path, and I'm going to paste in the place that I want these sources to look for the data. So I'll do that on both of them. And then I'm going to do something slightly different with the different data sources. So in source one, I'm going to have a look at the projection, and I'm just going to import the projection. And what you can see is it gives me the column names and the type of data that we're getting inside this source. Now on source 2, I'm not going to bother with the projection, but what I'm going to do is I'm going to have a look at the data preview. I'm just going to refresh it. And what this will do is it will go to the location that we specified, and rather than look for the projection, it's actually going to pull in a bit of sample data. Now this pulls in just a fraction of the data that's there. So if you've got large data sets, for example, if you have millions of rows, and if you're being very aggressive about the way that you want to filter that data, or if you're joining that data to other data sets, then you might want to change the number of rows that you get. And that's done in debug settings. So currently we get 1,000 rows for each, but you might want to expand that, because otherwise you might not get anything at all in your preview if you've got some aggressive filters. So the thing that I wanted to draw your attention to on this data preview is this map drifted, and we can see that both as a command there and also next to each one of the fields. And what this means is that I don't know anything about this in the source, and you'll see we have 0 columns here, whereas we've got 22 here. So comparing the data preview on these two, when we load it into the data source that knows about the data, you'll see we don't get any of that drifting at all. We can use that drifting to our advantage to some extent. So if I click map drifted, you'll see that it gives me a new transformation, derived column transformation, and inside that we have all of these expressions. So let's have a quick look at these expressions and see what they are. So the first part of it is the by name, and what this says is go and find me a column that has this name. So it's read the file and it's got the column names and it uses by name, and then it converts it to the data type that the file tells it has. So URL is a string, but you'll see that all of these are strings, and we can tell that because it's got this little ABC next to it. However, I know that appearances is a number, and I'm a bit smarter than the drifted columns derived columns wizard. So let's change this. So instead of a string, we're going to say to integer. And when I move away, you'll see that now instead of ABC, it says 1, 2, 3. So it tells me that it now knows that this is a number. Okay, so I'm just going to save and finish that. And what you'll see now is that we have two sources and we have this drifted column, but effectively, really, these two things now are doing the same thing. Okay, so what I would like to do now is just add a sync. And instead of the no parameters, what I'm going to do is I'm going to use the parameterized Parquet. And inside settings, well, you might think that here is where you would tell it where it's going to write, but there's not that in here. What there is, however, is this clear folder checkbox, and I just thought I'd bring it to your attention because this tells the data set that you either want to leave the data that's in the folder in place or overwrite it. So I'm going to check it for this example, and in the debug settings, you'll notice that now we have this parameter for sync1, and this really is where we would specify where it's going to write. Now, in terms of the data flow, all this is doing is allowing me to work further with this data flow. Where we would really specify this is in the pipeline that orchestrates or runs this data flow. But nonetheless, I'm going to add it here because I want to discuss a bit more about the other transformations that we can add. If you're familiar with Sys, then you'll recognize some of the transformations that we can add. You can see that we've got different types of inputs that we can have, so joins, unions, and such like. We can modify the data, aggregate, pivot, unpivot, and such like. in this example, I'm going to add a conditional split, and you'll see that when we do that, we have the facility to add a couple of streams, so female, and that will be the data that matches the condition we use. And the condition that I'm going to add to this is the gender equals female. And then my stream for data that doesn't match will be male. What I will then do is I'm going to transform this data a bit further. So what I would like to do is I'd like to get a average appearance for all of the female Avengers. So I'm going to add a new branch so that we've got different branch data. I'll add a select for this data. And what this does is it allows me to just move the data across, and when I come to bring the aggregates back in, then I've got all the fields that I want. So in this new stream, I'm going to add an aggregate, and within that aggregate, I'm going to not have any group bys because I just want to sum up data but by all of the fields, so all of the rows. And what I'm going to do is I'm going to add the condition that I want the average of appearances. And I'm going to call it average appearance. So now that I've done that, I can join the data back to the stream of all of the row data that I have that I want to append this to. So I'm going to use a join, and I'm going to tell it where I want to join the data to, where my right stream is. So that's aggregate 1, as we've just discussed. And because I want to add this to every row, I'm just going to use a custom cross join. And in the expression, what I'm going to say is that I want all of the appearances that equal average appearances or is true. So basically this is say just join to every row. So what I can then do is I can have a look at the data in my preview, and what this will do is it will pull all the data that I had for the female stream and then all of my aggregate data that has been joined. So what you'll see is that for all of the rows, I've got all of the data that I would expect to see, but right at the end, I've also got this average appearances value, and it's the same for every row. And that's great. That's exactly what I wanted it to do. Okay, so that's just exploring some of the kinds of aggregation you can do, but how do we actually run this? So what I will do is I'll create a pipeline and we'll get that to run this Avengers data flow. So I'll create a new pipeline, and I'll just hide some of this detail so that just to make it a bit more readable. Sorry, opened a window by accident there. And we will add to this an activity of a data flow. And inside the data flow, we've got a couple of things that we need to do. So the first thing is we want to tell it what data flow we want. So Avengers data flow, that's fine. And we also now need to populate the parameter that it's telling us, well, one of the syncs that you have has a parameter, so you need to add that. So I'll add that folder location here. If we run that, what you'll see is that down here we've got the same output that we saw before, and we'll probably need to refresh this a couple of times just to get it to run. I don't imagine it will take more than 10 seconds or so. But what we can also do once this is complete is we can look inside, and what this will do is it will give us some information. Hasn't completed just yet. It will give us some information about what happened to that data as it went through. So what you can see is that in our source we had our 173, we had 173 in map drifted 1, and then the conditional split brought out the 58, the aggregate only had 1, and then when we write out to the sink we had 58 rows. So it just gives us a bit of intelligence about how this data was processed. Great, so that's how we would build and how we would run data flows. Okay, now that we've run this pipeline, let's have a look at the data that it created. So we'll go and have a look at our storage, and we'll go to the Silver Avengers Female Members folder, and we'll see this Parquet file. And if we right click on this, we can see that we can start to run some SQL scripts. The first one, select 100 rows. Well, let's kick that off. And then you'll see that it brings back the data. And we know that this is the data that we've just created because if we scroll along, we can see this average appearances column that we had added. Another thing that we can do is we can create an external table. This starts to do a wizard, and we'll see that it's looking at the serverless SQL. We could change that if we wanted. If we had some other pools, we could use those. it's selecting a database, and in this instance we've got Avengers Death, we've also got Avengers Members, but I'm going to use the Avengers Death for the time being. And then we can say external table name. Well, I'm going to call this female Avenger, sorry for my typing, average. And we're going to use the SQL script. And the reason that we're going to do that is because we're going to amend this slightly before we go. So I'm just going to hide this to let us see this file a bit more clearly. And what I'd like to draw your attention to is a couple of things in the first instance. The first one is we're getting this external file format, and we're also getting this external data source. So what this means is that in the database that we're going to send this to, we get both a file format for this Parquet file, but also a location of where these files are going to be read from. So you'll see that the location is a kind of the high level. It's within the Data Scotland demo data store, but also in the container Data Scotland demo. Okay, so the next thing I'd like to just consider is the location. So what we can see is this is the location of this file, and you'll see that it's specifying this particular Parquet file. And that's fine, we can read from this file, but what happens if we add new files, or if we were, for example, to reprocess this data, this file name would change and our external table would be broken. So what we can do is we can take this and we can remove the name of the file, and we could replace it with a wildcard character. Or we could go a step further and we can say, well, actually, just read anything that's in that folder, and that works just as well. So if I run this, what you'll see is it will run through, and then it will produce the external table, and it will just select the 100 rows, as we can see at the bottom here. This last statement, select 100 rows from female Avengers average. So it will do that, and it will output the data that we saw. Now, what we can also do, if we look at the messages, you'll see that there's quite a lot of information there. But if I were to scroll to the bottom of that file, what you will see is that it tells me how much data it has read, how much data has been scanned. And I thought I'd bring that to your attention. It's kind of useful because for serverless SQL, we're paying for the data that we process. So if you've got some record of that, then that's a good way of finding that. Okay, so the last thing that I'd like to do is we've seen how that all works, but what we can also do is we can go to our SQL database in SSMS, and inside Avengers Deaths, we can refresh our external tables. And now we've got this female Avengers average, and we can script this to select 1,000 rows, for example. So it's just a way of showing that once you've got it into either the SQL databases, but if I were to refresh the databases as well, what you should also see is this Sparks database is also available through SSMS. So it's just to show that once you've got databases, virtual databases within your Synapse, you can access it through external tools. And that concludes the demo for. Okay, so hopefully we can agree from the demo that the elements of Synapse are quick to spin up. They are quite familiar to some of us that will have done similar things, so SQL integration services, for example, and that different people within your organization with different skill sets will be able to find elements of the platform that work to their strengths. And I think lastly, it offers the facility for a low cost and flexible platform. I had talked earlier about being able to repoint your integration runtime, and these are the commands that you would use to do that. So the first one, top line there, is just navigating to the location, and the second, the dmg cmd.exe, you need to add the key from your integration runtime to this command, but it is a quick and easy way to repoint. And then the last line on there is just how to restart. I'll just leave that up there for a moment just for those, but feel free to come back and watch the video and capture those. Just to finish, a couple of links. The first link there is documentation, the Azure Synapse Analytics documentation. It's quite extensive. And then the link below that is to Azure Synapse Pathway, and as I say, it's still in preview, so but it's good to get ahead of these sorts of things. And then lastly is my Twitter handle. So if you want to ask any questions, feel free to reach out and contact me then. Okay, thanks very much for attending this Data Scotland Summer of Data session. I hope you've enjoyed it, and I'd like to thank Data Scotland for giving me the opportunity to present to you today, and my first opportunity to present at a conference of this type. Thanks very much. Bye.